Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about trigonometry ratios in this video. Basically, I'm going to talk about the basic trig ratios here. I'm going to talk about sine, cosine, tan, cot, sec, and cosec, okay? In the next series, I'm going to talk about each of these in depth, okay? But I'm going to just introduce this in this video, basically, just the basic concept of this. So it's very important you review previous video before coming to this, especially understanding the concept on how we know which of a side of a right angle triangle is a hypotenuse, all right? All right, so the next thing as well, before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for, so that when I post new videos, you'll be the first person to know. Okay, so if we're talking about trig ratios, and when we're talking about trig ratios, most times we're talking about a right angle triangle. So, and I told you that if you have a right angle triangle, okay, right angle triangle you can have it in several ways, all right? So, but I also ensured that in the previous video, I told you that the side directly opposite the right angle, all right, or the 90 degrees is what we call the hypotenuse, right? Right. And we talked about this in the last time. Also, it does not really matter how the triangle look like, okay? So you can draw another triangle that looks something the opposite direction. Like this, okay? You can have a triangle like this. It does not really matter. It's still the same concept as well. So we have from this point all the way there, okay? So the same thing, because this is the right angle. So the side, which is the longest side, is what? The hypotenuse, right? All right. Now, also, even if you try to draw it upside down or in a different way, it's still the same thing. So it does not really matter. The hypotenuse, we talked about this one, we're talking about the Pythagoras theorem. So if you've not watched my video on Pythagoras theorem, please go back and watch it. So this side is also the hypotenuse, right? So it's basically the side directly opposite the right angle. All right. Now, but if we can fix an acute angle, then all right angles, triangles will have theta as one of their angles. So if, for instance, I decide to fix an acute angle, so because of that, we have an acute angle here. Let's call this theta 1. So we have an acute angle here. Let's call this theta 1. And that acute angle here, let's call it theta 2. Okay. Are you seeing it? So now, in order for this to make sense, I'm going to just be picking one angle just to explain the concept I want to talk about. So I'm going to start with theta 1. So that means you have one angle here, theta 1. Now, if theta 1 is the angle we are interested in, all right? So this theta 1 is the angle we're interested in. So now, in this case now, the interested angle, which is very important, the interested angle here is theta 1, okay? So the interested angle I have here is theta 1. Now, how do you now determine which is the opposite and the hypotenuse now? Sorry, the opposite and the adjacent. Now, we already established already that the side directly opposite the right angle is the hypotenuse, right? Now, also the side that will be directly opposite the side you're interested in. So I'm interested in this theta 1. So the side directly opposite to it, this is going to be the what? The opposite. Are you seeing it? So that means if, for instance, this is my theta 1, are you seeing it? So that means the side that is directly opposite to this, are you seeing it? This is going to be the what? The opposite. So if, for instance, in this example, this is the theta 1. Are you seeing it? The side directly opposite the angle is what? The opposite. Is this making sense? So that means in this case, when we're looking at theta 1, so where the opposite, okay, will be the angle or the side opposite theta 1. So that because in this case, we're interested in theta 1. Now, when we're done with that, then the adjacent now the adjacent will be equal to the what? The remaining side. Are you seeing it? So now, because you know this is the hypotenuse already, that has been already been sorted out. So that means this side here is going to be the adjacent. Are you seeing it? This side here is going to be the adjacent. And this side here is going to be the adjacent. And that is that. And that is it. So the hypotenuse, I'm going to just write this again because we already talked about it already. But we already know that the hypotenuse is the side that is opposite the right angle, right? So it's the side opposite the right angle. Just to complete the sides, okay? So opposite the right angle. Okay, that's interesting. Okay, but another thing as well you need to know is that in addition to theta 1, like I said earlier, there is going to be another angle which we have here, which is the theta what? 2. Are you seeing it? So that means in this case here, the angle here is going to be the theta what? 2. And the angle here is going to be the what? The theta what? 2. Okay. So now, we said this was the adjacent, right? Now, let's go back now. So now, if we are interested in theta 2, so that means if we're just interested in theta 2 now, you will see that in this case, so that means the interested angle so in this case, the interested angle now is theta what? 2. So now I'm not interested in theta 1, I'm interested in theta 2. So what are we going to do? So to make it easy, I'm going to just copy this as well and see if I can bring it down here. If not, I'll just draw it all over again. Let's see if it's going to work here. See if I can paste it here again. Oh, no. So it didn't work as I expected. So what I'm going to do is I'm going to pick this triangle. All right, let's pick this one and see. Okay, so pick this and see if we can drag it all the way down here. Yep, so we have this one. We have this triangle here. So it's not as good as I want it to be. So I'm going to just use this one again so that it should not be, I don't want to have it so muddled up. So now if we're looking at theta 2 now, all right? So theta 2. Now for theta 2, the side that is going to be opposite it is going to be what? The opposite. So now because in this case, it was the adjacent for theta 1, but it's going to be the opposite for theta 2. So let's, I think I'm going to drag it. Let's do it this way. Okay. Then let's see this way. See if it works now. Yep, it did. So now we have this. Okay. We have this. So you have for theta 2. Now, if you want to draw this again, so initially we had this as like this. So, but if you now want to have a look at this more closely, we have this one and that one, and we had this. Okay. And we're looking at theta 2 here. Are you seeing it? And we had this part to be theta 1. Okay? This was theta 1, and that was theta 2. Now, using theta 2, now, in this case now, the side that is directly opposite theta 2 is going to be the opposite. Are you seeing it? But when we're using theta 1, the opposite was on the other side. Now, we already agreed that this is what the adjacent, or the right, if this was the right angle, for instance, this is going to be the hypotenuse. So that means the adjacent is going to be the remaining side. Okay? So that means the remaining side is going to be the adjacent. So that means in this example, we can see that the opposite for theta 2, when theta 2 is what you're interested in, is not going to be the same opposite for theta 1. So now in this case now, this is the hypotenuse, this is the side, directly opposite. So you can see in both cases, both for theta 2 and theta 1, the hypotenuse is constant because it's just the side opposite the right angle triangle, all right? So the same thing, if you take the other triangles as well, and you try to draw it as well, it's going to be exactly the same thing. See if we can paste it here. See if we can drag it a bit here. Okay, so the same thing. Let's see if we can also break this down. So now we have another triangle. So let's break this one. Let's look at this triangle here. All right. So we have the same thing. We have this one. We have this one here. And we have that one. So from that, we know that this is the right angle, okay? And because it's a right angle, the side opposite it is going to be the what? Hypotenuse. Okay? We know that this side here is going to be theta 1. And this side here is going to be what? Theta 2. Now, when we use theta 1, the opposite was this. Now, because the side we're interested in is theta 2, so that means in this case now, for this triangle, this is going to be the opposite. Then the remaining side is going to be the adjacent. Okay? Now, if we want to use the other, look at the other triangle as well. Okay? And you want to draw it. But the same thing, you have a triangle here. You have something like this. And you have something like this. Are you seeing it? So we have this. So this part, this is the right angle. So that means the side directly opposite this is the what? The hypotenuse. Are you seeing it? Now, so but in the previous one, we knew that this was theta 1. We're told this is theta 1. And this is going to be what? Theta 2. Okay. Then we're told that theta 1, this was the opposite, but because we're looking at theta 2, we're interested in theta 2 now, the opposite is going to be this side. So that means in this side here is the opposite, while this side here is going to be the adjacent. So you can see that it's very important that you see that when the interested angle is theta 2, the opposite and adjacent are not the same thing. So it's very important for you to determine which is the angle you're interested in. So that means when the angle you're interested in, when is theta 1, the sides, the opposite and adjacent are not going to be the same. So we're going to have the same thing. So in this case here, we have where, all right, the opposite. So the opposite is going to be equal to the side opposite theta. Number 2, we have the hypotenuse. We've already agreed that the hypotenuse is the side that is opposite the right angle. And the last one is the adjacent. So the adjacent is the what? The remaining what? Side. The remaining side. So depending the angle you're looking at, okay, if it's theta 1 or it's theta 2, okay, will determine which is the opposite, okay? So like you can see, when we're looking at theta 1, okay, when we're looking at theta 1, the opposite was different, is the adjacent when we're looking at theta 2. So it's very important to have that in mind while solving. Okay, we're done with this now. So let's go to the next part. So I will want to talk about a quick summary of what we're going to discuss in this video. Because the trig ratio basically is the ratio of two sides of a right angle triangle with respect to a particular acute angle. And one of the things you need to keep in mind is that since the sum of an angle is equal to 180, we know already from the previous videos that the sum of an angle of the angles in a triangle is 180 degrees, okay? So the sum of an angle in a triangle is 180. And also you can see that means in a triangle, if we go back to the triangle we've been drawing, you can see that from what we've been doing for the last few minutes, you will see that for every triangle, we are having theta 1, theta 2, and a right angle triangle. So we have this, okay? We're having this one. Is a black pen, yep. And I told you we have theta 1 and we have theta 2, okay? So that means from this now, I can now tell you, since the sum of an angle is 180, so I can now tell you that, and we know it's a right angle means is 90 degrees. So that means everything, when you add up all this, it should give you 180 degrees. So that means 90 degrees plus theta 1 plus theta 2 must be equal to what? 180 degrees. I'll take 90 degrees to the other side. So you have theta 1 plus theta 2 will be equal to 180 minus what? 90 degrees. So then this will now give me theta 1 plus theta 2 to be equal to what? 90 degrees. And this is the rule you need to know. In a right angle triangle, okay, the other two angles, when you add them together, they should give you what? 90 degrees. So For those that are taking notes, this is an important concept you need to write in your notebook. So now, how do we now go about this trig ratio? So the trig ratio is the ratio of the two sides of a right angle triangle with respect to any acute angle. Let me write it down because I know some students will take notes from what I say. So the trigonometry ratio, okay, is the ratio of two sides of a right angle triangle with respect to any of the angles. Any of its acute angle. Okay? So with respect to any of its acute angle. So let's see now. All right. So that's what we're going to talk about. So how do we now find these trig ratios? In this series, we'll talk about two things. All right. We're going to talk about the basic trig and the inverse of basic trig. Advanced trig, I've talked about, I'll have another series on advanced trig where we talk about in depth of these trig ratios. But in this video, I'm just going to talk about the basic trig for starters. Then later, we'll now talk about in depth on how do we go about each of this. So basically, what I'm saying is that we're going to talk about two things. So under trig ratios or trigonometry ratios, there are two concepts I'm going to discuss here. I'm going to talk about the basic trig, okay? So I'm going to talk about the basic trigonometry, and I'm going to talk about the inverse of basic trigonometry, okay? I'm going to talk about the inverse of basic trig, okay? So I'll go talk about the inverse of basic trig. Now, under the basic trig, there will be three things I'm going to talk about. I'm going to talk about the sine, okay? Usually it's written as SIN, okay? And I'm going to talk about the cosine, all right? The cosine is written as cos, all right? And I'm going to talk about the tangent, okay? So I'll talk about the tangent, and that's written as tan, all right? Now, for the sine, there'll be two things I'll talk about. So the concept of sine is usually written as opposite divided by the hypotenuse. Okay, so the cosine is usually the adjacent. So that's why it's very important to know the angle you're talking about divided by the hypotenuse. And for the tangent, it's going to be the opposite divided by what? The adjacent. So there is a mnemonic we have for this. It's called the Secant. So some of you might have heard of this before. So the Secant, all right? So the S stands for the sine, all right? So the S is for the sine. So opposite over hypotenuse. The C is for the cosine. That is the adjacent divided by the hypotenuse. And the T is for the tangent, which is opposite, divided by what? Adjacent. So some of you might have heard of this SOHCAHTOA before. It's a way to remember this. So the sine is the opposite of a hypotenuse. The cosine is the adjacent of a hypotenuse, and the opposite is equal to the tangent is the opposite over the adjacent. Okay, so now let's go to the next one. So for the inverse, all right, so the inverse of trig, there are three things we'll also talk about as well. We'll talk about the cosecant. Okay, now some textbook will write it as cosec, or some will write it as CSC. Write this better. So some write it as CSC, all right? Now, this is the same thing as saying 1 divided by what? Sine, okay? 1 divided by sine. Now, the 1 divided by sine, so since we have sine, it's opposite of a hypotenuse, so you flip it. So in this case now, it's going to be hypotenuse over opposite. So it's going to be hypotenuse divided by what? Opposite. Now, the next one, we're going to talk about the secant. Okay, so usually called sec, all right, which is equal to 1 divided by what? The cos, all right? So 1 divided by the cos. So here we have adjacent divided by hypotenuse. So you flip it now. It's going to become hypotenuse divided by adjacent. So it's going to be hypotenuse divided by what? Adjacent. And the last one we'll talk here is going to be what we call cotangent. The cotangent is what we call the cot, which is equal to 1 divided by what? Tan. And 1 divided by tan. So you have to check the tangent. The tangent is opposite over adjacent. And that will give us adjacent over what? Opposite. All right. And these are what we're going to talk about in this video. So I'm going to talk about the basic trig, the inverse of a basic trig. And so the sine, the inverse of sine is the cosecant. The inverse of cosine is secant. And the inverse of tangent is cotangent. All right. So we're going to solve some questions on this now. All right. So I'm going to take this one at a time, and it's going to be a little bit long video. So I'm going to go from each of them. So we'll have everything in this video. All right. Okay, so let's get started. So before I proceed, let me write down the rules for this, okay? So similarly to what we talked about in Pythagoras, we have 3 steps, okay? 3 steps, or you can call it 3 rules, depending on which one you prefer. So number 1, the first thing you have to do is that you have to identify the A, B, and C. So that means basically you're identifying the opposites, the adjacent, and the hypotenuse, okay? So you have to identify the appropriate what? Or let's say identify and label. To identify and label the appropriate sides. So that means you need to know which is the hypotenuse, which is the adjacent, and the opposite. Then after you're done with that, the next thing you do is that you use the relevant trig ratios. And when you're done with that, number 3, you then what? You then simplify. Okay, so first thing you identify, you label the appropriate size. After that, you use the relevant trigonometry ratios. And number three, what you do then, you then simplify. All right, let's pick an example, okay? I'm going to just pick an example and see if I can use this to explain the concept of both the basic trig and the inverse of basic trig, just to explain. So let's assume, assuming we have this triangle. Okay, let's assume we have this triangle here. Okay, so assuming we have this triangle and we're told that this is 4 centimeter, we're told that this is 3 centimeter, and we're told that this is 5 centimeter. Okay, and in this now we have the theta to be here. Okay, and definitely this is a right angle triangle. Good. Now, I'm going to use this triangle to explain all the concepts. So step one, we're told that we need to identify, right? We need to identify and label appropriately. So what we're going to do, so quickly, to make it fast, well, you know that this is a right angle triangle, and this is the angle here. So that means this 5 is going to be the hypotenuse. So the 5 is going to be the hypotenuse. All right, so the hypotenuse. Okay. Now, since in this example, we are interested in this theta now, right? So remember, like I said previously, that is the side facing the angle I'm interested. So in this case, I'm interested in this theta. So that means this side here is going to be the what? The opposite, all right? This is going to be the opposite, and the adjacent is going to mean the remaining side. So this is going to be the adjacent. Okay. So that means I've identified and labeled all this. All right. So I'm going to use this now to do the basic trig. So just to quickly summarize the basic trig, I'm going to use this triangle to do all that together. So now let's start with the basic trig, A now, all right? And I told you that the basic trig, trigonometry, or you can call it trig. So I'm going to be calling it trig in this video. So to avoid saying trigonometry, just trig and trigonometry. Trig is just a short form for that. And I said the mnemonic for this is SOHCAHTOIS. All right? So the basic trig is SOHCAHTOIS. All right. So now let's do this. So now, regardless of the trig identity you use, you will get exactly the same thing. So that means for this theta, no matter the trig identity I solve with for theta, I'm going to get the same answer at the end of the day. All right, so let me prove it to you. So now we know that for this now, we know sine, which is so, all right? So because we know that this is for the first one, we know that sine theta is going to be the opposite divided by the hypotenuse, right? So it's going to be the opposite divided by the what? Hypotenuse. Okay, so that's the first one. So now, so therefore we can now say sine theta is going to give us, what's the opposite? 3 divided by, what's the hypotenuse in this case? The hypotenuse is 5, which is going to give us 3 divided by 5. But we're not looking for sine theta, we're looking for theta, all right? So now in order to get theta now, so theta will going to be equal to get this sine out, you're going to find the sine inverse of what? 3 over 5. Are you seeing it? The sine inverse of 3 over 5. So to make theta sort of the formula, you get the sine inverse of 3 over 5. And when you press your calculator for that, it's going to give you 36.87 what? In degrees. Are you seeing it? All right. So now let us use cosine now. Let's try with cosine and see if we get the same thing. So the same thing, number 2, we have cos theta. Now cos theta is equal to the adjacent divided by the what? Hypotenuse. Okay? So the adjacent divided by the hypotenuse. So therefore, we can now say that cos theta will be equal to, now let's go back here and see. Now the adjacent we have is 4 and the hypotenuse is 5. So that means it's going to give us 4 divided by 5. And then theta is going to become the cos inverse of 4 divided by 5. And that will give us 36.87 degrees. Okay? Then finally, let's try with tangent now. Okay, let's try with tangent. So we have tangent. Tangent is the opposite divided by the what? Adjacent. So the tangent is opposite divided by what? The adjacent. So number 3, tan theta is equal to the opposite divided by what? The adjacent. So therefore, tan theta will be equal to, what's the opposite here? So the opposite is 3 and the adjacent is 4. So it's going to give us what? 3 divided by 4. So therefore, theta is going to be equal to the tan inverse of 3 divided by 4. And that will give you what? 36.87 degrees. All right. So you can see that regardless of the basic trig identity I used, I still got the same answer for theta to be equal to 36.87. Okay? Now, let me use the inverse of basic trig identity and see if you're going to get the same thing. So number 2 now. The next one I'm going to use now, the B. I want to use the inverse of basic trig. All right? The inverse of basic trig. Now, the reason why I'm using this is that sometimes some students are always fixated on using a particular trig identity. So what I'm just trying to show you here that regardless of the trig identity, provided that those trig identity are correct, okay, and you use the appropriate trig identity and you substitute correctly, you should get the same thing. All right? All right, so let's go now. Let's find, let's assume I want to use the first one. I want to use cosec theta, okay? So we have cosec theta is equal to 1 divided by what? Sine what? Theta. Are you seeing it? Does that make sense? Now, but before we get into this, or let me make it easier, all right? Let me make it easier. So we know that cosec theta, if you go to the previous slide, I told you that cosec for this, or cosecant, is 1 over sine, which is hypotenuse divided by what? Opposite. Okay? So hypotenuse divided by opposite. So that means we know that cosecant is equal to hypotenuse divided by what? Opposite. Right? So let us go. So let's go to the diagram. What is the hypotenuse? The hypotenuse here is 5, and the opposite is 3. So the hypotenuse is 5, and the opposite is what? 3. Now, if you look at this more closely now, we know that now we can say that cosec theta is equal to 5/3. But we know that cosec is the same thing as saying 1 over what? Sine theta. So because if you go back, I told you that cosec is 1 over sine. Does that make sense? 1 over sine. So that means cosec is 1 over sine theta. So, and this is the same thing as what? Equal to 5/3. Are you seeing it? Now, we're looking for theta first. So the first thing I'm going to do is that I'm going to flip this side, and I'm going to flip this side. So I'm going to flip the one by the left-hand side, and it's going to give me sine theta divided by 1. And I'm going to flip this side, and it's going to give me 3 divided by what? 5. Now, but I'm looking for theta, okay? Because it's sine theta divided by 1. It's still the same thing as saying sine theta is equal to what? 3 over what? 5. Now, but we are looking for theta. So theta will be equal to the sine inverse of 3 over 5. And that should give you what? 36.87 what? Degrees. Are you seeing it? We got exactly the same thing. Now, let us try the next one. Let us try with sec. All right, let's see whether we get the same thing with sec. This should be number 2. So that's II. So sec theta. Now, when we go back to that previous page for sec, so we know that sec is equal to hypotenuse divided by what? Adjacent, okay? Hypotenuse divided by what? Adjacent. So sec is equal to hypotenuse divided by what? Adjacent. Now, let's go to the diagram now. So let's see which is the hypotenuse and which is the adjacent. So the hypotenuse in this case was 5, and the adjacent was 4. So hypotenuse was 5, and the adjacent was 4. Okay? So that means I can now say that my sec theta is equal to 5 divided by what? 4. Now, sec now. If you look at sec more closely, I told you from the previous slide that sec is the same thing as 1 over cosine, all right? So sec theta is going to be 1 over cos theta then. So that means sec theta is going to give us 1 over cos theta, which is going to be 5 divided by 4. So what do? I'm looking for theta, so I'm going to flip the left-hand side and also flip the right-hand side. So I'll flip the left-hand side, so cos theta divided by 1 will be equal to what? 4 divided by 5. So therefore, I can now say cos theta will be equal to 4 over 5. But I'm not looking for cos theta, I'm looking for theta. So theta is going to be equal to the cos inverse of 4 over 5. And when you press your calculator for that, it's going to still give you the same thing as 36.87 degrees. Okay, so you see, using sec, using cosec, we are getting the same thing. All right, let me throw in the last one, which is cot now, and see if I'm going to get the same thing with cot. So number 3, we have cot theta. All right. Now, if you go back to the previous slide for cot, so we can see here that for cot is 1 over tan, which is the same thing as adjacent over opposite. Okay. So adjacent divided by opposite. So that means cot theta is equal to adjacent divided by what? Opposite. Now, if you go back to the video, the example we had, what is the adjacent here? The adjacent here is 4, and the opposite is what? 3. So it's going to give us equal to what? 4 divided by 3. So I can now say that cot theta is equal to what? 4 over 3. Now, but we can't press cos theta in your calculator, so we go back and see what does cot theta represent. Cot theta is 1 over tan. So we're going to do this. So cot theta, I can write this again as 1 over tan theta equal to 4 over 3. So the next thing, I'm going to flip the left, I'm going to flip the right. So this is going to give us tan theta over 1 will be equal to what? 3 over 4. So therefore, based on this now, I can now say that tan theta is equal to 3 over 4. All right? So tan theta is 3 over 4. So that means to get theta now, theta is going to be equal to the what? The tan inverse of what? 3 divided by what? 4. So the tan inverse of 3 divided by 4. And this is going to give me the same thing as 36.87. So as you can see, I use the basic trig, I use the inverse of basic trig, and I still got the same theta as 36.87. Now, from this now, I can easily, without stress now, I can get, let's assume here was B, all right? It does not matter. I can get the value of B now. So because I know theta 1 is 36.87, all right? So that means I know this angle now. This angle is 36.87 degrees. So I can get B now, angle B. Now, if you go back, I told you that the sum of an angle in a triangle is 180. The sum of an angle in a triangle is 180 degrees. Okay? So that means if I add up all these angles here, it's going to give me 180 degrees. Or, remember I told you as well in the previous video where I said theta 1 plus theta 2 is equal to what? 90 degrees. So you can use any of this and you will get the same thing. So that means I'm going to use the first one just to make it easy for me. I know that the sum of the angle is 180. So that means the right angle, which is 90, plus the theta plus B must be equal to 180. Are you seeing it? So that means the three angles here, which was theta, because we know this is 90 degrees, all right? Plus B must give you 180. But we also know that we know the value of theta already to be 36.87. So because we know the value of that, we can rewrite it again. So it's going to give us 90 plus 36.87 plus B must be equal to 180 degrees. I take all this to the other side. So B is going to become 180 minus 90 minus 36.87. And B is going to give you, when you press your calculator, 53.1 degrees, okay? 53.13 degrees. Or if you don't want to use this method, you want to use the other method I talked about. So this is method 1, okay? If you don't want to use this method, you want to use method 2, where I told you that theta 1 plus theta 2 is equal to what? 90 degrees for a right angle triangle. So that means in this case, it's going to be theta plus B must be equal to 90 degrees. So B is going to be 90 minus theta. And our theta was 36.87. So the B is going to be equal to 53.13 degrees. So any method you use, you should get the same thing. So The reason why I went through all the steps is to show you that regardless of the method you use, you should get the same answer. So find the trig ratio you use is what? Very correct. All right, so let's pick some examples now. All right, let's pick some more interesting example and try. Okay, so let's pick some examples now and see if we can solve them. All right, so number one, we're told now that find the length of x. Okay, for the triangle below. Okay, we're told to find the length of x for the given triangle below. So this was the triangle that we have here. Okay, the triangle, and we're drawing this one this way, and we have another from this point to this point. Okay, and we're told that this is 10 centimeter. This was 60 degrees. Okay, and we're looking for x here. So we're looking for x centimeter. And definitely, you know, this is a right angle triangle. All right, and we're told to find it. So similarly, we use the same method. You have to identify and label all the sides correctly. You use the relevant trig ratios and you simplify, right? So let's do this now. So step one. All right. Now, definitely, you should know that this side is opposite the right angle. So that means the hypotenuse here is going to be 10 because opposite the right angle. So the hypotenuse here is going to be what? 10 centimeter. Okay. Now, because this is the angle we are interested in or we are using here, so that means the side that is directly facing it here is going to be the opposite. So that means x is going to be the what? So the opposite is going to be equal to x what? Centimeter, right? Now, step two now. We need to now use the appropriate, what do you call it? The appropriate formula for this. So step two. Now, what is going to be the appropriate formula now? So remember, we have, it's called Secant. Okay, it's Secant. So we have it as hypotenuse. We have hypotenuse and opposite. So we can't use tangent because it's opposite and adjacent. We can't use cosine because adjacent and hypotenuse, but we can only use sine because it's opposite and hypotenuse are given. So that means we can now solve this. So we know that sine theta is going to give us the opposites divided by the hypotenuse. Okay, so sine theta is opposite divided by hypotenuse. So then we're going to have, so the theta here, because the angle we're interested in, the theta was what? 60 degrees, right? So we're going to go back now and do the same thing. So it's going to be sine 60 degrees is going to be equal to the opposite. In this question, was the opposite x centimeter divided by the hypotenuse, which was what? 10. All right, so we're looking for x here. So what do you do? To get x to be on its own, I'm going to multiply both sides by what? 10. So I'm multiplying both sides by 10. Okay, so that means this 10 will cancel this 10. So therefore, the x will be equal to 10 multiplied by sine what? 60. Then step 3. What is the next thing to do? So step 3, x will be equal to 10 times sine 60. And when you press your calculator for that, it's going to give us 5√3 centimeter. All right. Or you can solve this in decimal places, depending, okay, on what you have. So that means in this case here, the x that we have here, okay, is equal to 5 root 3 centimeter. 5 root 3 centimeter. And that is that for that. Okay. Now let's pick another question here and see if we can solve this. All right. So it's very important you go to the textbook, the formula sheet, and see if you can solve more questions on this. So number 2, all right, we have another question. They said find the value of theta, sine theta, and cos theta if tan theta is equal to 1/2. Now, this is interesting because in this case now, they've given you a trig identity or a trig ratio, and they want you to find the value of other trig ratios. So it's interesting here. So how do you go about it? So for me, I can go straight and solve this, but because I'm teaching a large audience of subscribers, what I'm going to do is I'm going to break it down so that it will make more sense to you. Now, so first thing first, because it's a tan, let's draw the triangle so that it will make sense to us, okay, and see what the writer is trying to convey here, okay? So let's see, we have something like this. And now we have, we're told theta, so you can use anyone. You can use, let's assume this is the theta, right? So you can be anywhere. So like I said at the beginning, depending the theta you're interested in will determine the value you're going to look at here. Now, but we're told that tan theta was 1/2. So that means let's go. We have so car toi. Okay. So car toi. So we know that, I beg your pardon. So we know that tan is opposite divided by adjacent. So we know that tan theta, okay, from what we've learned, is going to be the opposite divided by adjacent, right? And we're told that the tan theta was 1 divided by 2. Are you seeing something here? So that means I can easily say from what we're told here that therefore the opposite then must be equal to 1. Are you seeing it? The adjacent must be equal to 2, right? Good. So now let's go back to the triangle. So if this is theta, I can easily say that we already know that this is a right angle. So that means this part here is the hypotenuse. So this part here is going to be the what? The opposite. Okay. And therefore, the remaining side here is going to be the what? The adjacent. So that means if we know that the opposite is 1 and the adjacent is 2, so that means I can easily now say that for this triangle, the opposite here, this is 1, and the adjacent here is what? 2. So, or to avoid any form of confusion, so I can say this is going to be the adjacent is going to be 2 centimeter, and the opposite is going to be equal to 1 centimeter. So that means I can redraw this triangle again. Okay, if I want to make it clearer now, I can redraw this triangle and it will make more sense to you now. So that means this is exactly the triangle that the writer had in mind. So that means if this is theta, this is going to be 2 centimeter. This is going to be 1 centimeter. And this is the right angle triangle. So now we have deciphered this clearly and easily now. So now let's find the hypotenuse, right? And that will make it more interesting before we go down to start finding the angles, okay? And from the previous video, I talked about the Pythagoras theorem. So if you've not watched my video on Pythagoras theorem, this will be a good time for you to go back and have a look. So now let's use Pythagoras theorem now. So using Pythagoras theorem, okay? Now let's use Pythagoras theorem here, all right? Now, so as usual, I told you in Pythagoras theorem, the most important side you just need to know is the side that is opposite the right angle. And in this case, it's going to be the C. So you can now make any of this your A and B. It does not really matter, all right? So we know from Pythagoras theorem that C squared is equal to A squared plus what? B squared, okay? So therefore, we now know the C is going to be equal to the square root of A squared plus B squared, which is going to be equal to the square root of A is what? 2 squared plus B is 1 squared. So therefore, we can now say C is going to be equal to square root of 5. So now we can now go back now, and we can now write that now we know that the hypotenuse in this case now is equal to the square root of what? 5. So we now have the complete set. So we now know that in this example, we know the opposite is 1, okay? The height adjacent is 2, and then the hypotenuse is now equal to square root of 5. Now we are done. Now we can go and find theta now, all right? Because the question wants us to find theta, sine theta, and cos theta, all right? So now we can find theta now. So number one, to find theta, so like I did earlier, you can use any of the trig ratio you want to. And for me, you can use either the basic or the inverse. It does not matter. Like what we did there, you will get the same answer, all right? So what I'm going to do, I want to use, because I have all the sides, I'll prefer to use sine theta, all right? Which is the opposite, okay, divided by the hypotenuse, okay? So just in case you've forgotten what I'm talking about, I'm still talking about the SOHCAHTOA, all right? So the SO there is the opposite divided by the hypotenuse, right? So if you want to do this again, you can try this with a cosine, you will get the same thing. You can try with a tangent, you will get the same thing. So sine theta, so the opposite here, if you take it up, the opposite is 1, the hypotenuse is root 5, okay? So it's going to give us 1 divided by what? Root 5. So like I said, when we talked about source and indices, you can have, what do you call it? You can have source at the denominator, all right? So you have to rationalize the denominator. So it's very important to do that. So let's proceed and do this. So what I'm finding here, I want to find sine theta first before we start finding the inverse. So to find sine theta, all right? So theta is 1 over root 5, but I can't have 1 over root 5. So what will I do? So I'm going to rationalize the denominator. So sine theta will be equal to 1 over root 5. So I'll times by root 5 divided by root 5. So that will give me root 5 divided by what? 5. So usually when you press your calculator, the calculator will automatically give you root 5 over 5 because your calculator is going to rationalize it automatically for you. So, but it's very important you understand this concept, all right, when you're solving. So we can now say, so therefore for this now, sine theta will be equal to root 5 divided by what? 5. Okay. Now the question also wanted us to find cos theta, I believe. Yes, it wanted us to find cos theta as well. So same thing, Socatoire. So number 2 to find cos theta. So for cos theta, we're interested in the car, Socatoire, right? So car is adjacent divided by hypotenuse. So that means we know that cos theta is equal to the adjacent divided by the hypotenuse. All right. So when we go back now, what is the adjacent? The adjacent is 2. The hypotenuse is root 5. So we can now say that cos theta is equal to the adjacent is 2 divided by what? Root 5. The same thing we have here. You can have roots as a denominator. So you're going to multiply, you rationalize it. So if you've not watched my video on source and indices, it's a very good time for you to pause and go to the video, go to the playlist and select the video title. I think it's called Rationalizing the Denominator. So you have a look and refresh yourself about this. So when you do this, it's going to give us 2 root 5 divided by what? 5. So now, therefore, we can now say that the cos theta is equal to 2 root 5 divided by what? 5. And that will be that for that. Okay? So, and the last part of that question wanted us to find theta as well. Yes, so wanted us to find theta. So that is easy. We have a sine theta, we have the cos theta, and the question also gave us tan theta. So we can use any of these to get the answer. So I'm going to use all of them, all right, just to explain, all right? But in the exam or in any related exam you have or any worksheet, one will be fine, all right? If you use any of them, you should get the same thing. So now this time we want to find theta, okay? So we can use cosine. So we know that cos theta was equal to 2 root 5 divided by 5. So then theta is going to be equal to the cos inverse of 2 root 5 divided by 5. And when you press your calculator for this, it's going to give us 26 point what? 57 degrees. Okay. Now, if for instance another student prefer to use sine, we can use sine theta. Sine theta is root 5 divided by 5. So sine theta is equal to root 5 divided by 5. So therefore, theta is going to be equal to the sine inverse of root 5 divided by 5. And this is going to give us the same thing, 26 point what? 57 degrees. Then the last one is that we can also use tan theta. I think that was given in the question as well. So if you go, I think the question said tan theta is equal to 1 over 2, right? So now let's do that. So tan theta is 1 over 2. So therefore, theta is going to be equal to the tan inverse of 1 over 2. And that will still give you what? 26.57. So you see that regardless of the method you use, you're going to still get theta, which is what you're looking for, to be 26.57 degrees. And that will be that for that. All right, let's pick another example. Okay, and let's pick another example to further explain this. So let's assume if we're told that if cos theta is equal to 8 divided by 9, we're now told to now find sec theta, cosec theta, cot theta, and theta. Okay, we're told to find this. So given that it is a right angle triangle. Okay, given it is a right angle triangle. All right. So let's see how we'll proceed with this. All right. So let's start. So we're told that cos theta is equal to 8/9. So that means if you remember the same thing, we have the secant. Okay, so that means the cosine, which is adjacent and hypotenuse. So that means we can say cos theta is equal to adjacent divided by what? Hypotenuse. And that will give you, so the adjacent is 8 divided by 9. Okay, so from this now, I can easily say now that the adjacent in that triangle was equal to 8. The hypotenuse in that triangle was equal to 9. All right, so let's draw this triangle and try and see what it was. Okay, so we have, I'll do this the other way around. So let's just make it like looking like this. So let's assume it's a right angle triangle. Okay. So just for fun, I'm gonna just put a theta because normally in most books they always put the theta to be here, but now I want to make the theta here. All right, just to make it more interesting. Okay. So now, so this is a right angle. So that means this. So that means definitely this side here is gonna be the hypotenuse. All right. Now, this side that is directly opposite the theta, okay, is going to be the opposite. And the remaining side is going to be the adjacent. Okay. Now, if you look at it now, we're already told now that the adjacent was 8. So that means this here is 8. And we're told that the hypotenuse was 9. Hypotenuse was 9. Are you seeing it? So we can draw this triangle again. Okay, so let's draw the triangle again to make it clearer. So we can have this. We can have, nope, this one. We can have something from this point here. Oh, no, draw this again to be straight. So we have, yep, like this. And we have like this. Okay. So, and we have the theta now. We have the theta to be here. So we know this is the 9 centimeter, or depending what was given. And this is what? 8. Okay. And this part here was 8. So this is a triangle, and this is a right angle triangle. So we want to find this. So the same principle as well, I'm gonna use Pythagoras to get this side here, all right? So like I always say, if you've not watched my videos on Pythagoras, please, this is a very good time to go back and watch the video. So using Pythagoras theorem, okay? I'm going to use Pythagoras theorem here. Okay. So like in Pythagoras theorem, the hypotenuse, which is the C, so that means in this case, 9 is equal to the C, okay? So that means let's assume that this is the A, all right? So let's assume this is the A, and this is gonna be the B we're looking for, all right? So this is what we're looking for. So now we can now proceed with this to solve. So we know that B squared will be equal to C squared minus A squared. So therefore, B will be equal to the square root of C squared minus A squared, which is going to be equal to the square root of 9 squared minus 8 squared. And when you press your calculator for that, it's going to give you square root of what? 17. So that means we can now say the B is equal to square root of what? 17. So that means now we can go back here and rewrite this now. So instead of having the question mark now, we know that this is equal, the opposite now is square root of what? 17. And also, I can now go back here now and say as well that for this diagram, the opposite as well, the opposite is equal to square root of what? 17. Are you seeing it? So with that now, that's the hardest part that I've been done now. So now we can now go straight and start solving for finding the sec, cosec, and cot. All right, so let's start with sec, okay? So to find sec, so number one, or let's say A, to find sec, okay? We need to find sec theta, okay? Now, the first thing we need to know is that what is the formula for sec, okay? And for me, to make it very easy, I would prefer to first find all the basic trig identities, okay? So let's find the trig identities first. So let's find all the basic trig identities. So let's find the basic trig identities first for each of them, okay? So the basic trig ratios, I beg your pardon, for each of them first, then before we start finding the inverse of the basic, okay? So let's start with the first one. So we know sine theta. So remember the basic trig identity is SOHCAHTOIS, okay? So the sine is the opposite of a hypotenuse, the cosine is adjacent of a hypotenuse, and the tangent is opposite of an adjacent. So now we can now say sine theta from the SO, okay, is equal to the opposite divided by the what? Hypotenuse. Okay, and that'll be equal to the opposite in this example. The opposite was root 17, hypotenuse was 9. So it's going to give us root 17 divided by what? 9. So therefore, we can now say sine theta is equal to root 17 divided by 9. Okay, so that was that for that. Now let's go to the next one, cosine. So cos theta is equal to, as a car now, is adjacent divided by hypotenuse. So the adjacent divided by what? Hypotenuse. Now, what's the adjacent here? So we go back there to the triangle. The adjacent was what? 8. And the hypotenuse is what? 9. So the adjacent is 8 divided by the hypotenuse, that was 9. So therefore, we can now say cos theta will be equal to 8 over 9. Then the next one, we have tan theta will be equal to, we're talking about the toi now, right? The opposite of adjacent. So we have the opposite divided by the what? The adjacent. So now what's the opposite here? Is root 17 divided by 8. So it's going to give us root 17 divided by what? 8. So therefore, we can now say that tan theta is equal to root 17 divided by 8. Now, so we've gotten the basic now, right? The basic trig identity. So now we can now go straight and start looking for each of this. All right, so let's start. Sec theta. So let's go with the first one. We want to find sec theta, and let's see what would that give us. So sec theta. So to find sec theta, so we know that sec theta. So sec theta, if you go back, I told you that for this one, sec is 1 over cosine, right? So we're going to go back to sec theta. So it's going to be 1 over cos theta. And that will be equal to, so let's go. So we have our cos theta to be what? 8 over 9. So that means it's going to be 1 divided by 8 over 9. And that will give us what? 9 over what? 8. So therefore, sec theta is equal to 9 divided by what? 8. Okay? Number 2. Next one we have is cosec theta is equal to 1 divided by what? Sine theta, right? So please make sure you are very conversant with these trig identities. It's very important. To be 1 over sine theta. So let's go. So what did we solve to get for sine theta? So sine theta, we got root 17 divided by 9. All right, so root 17 divided by 9. So it's going to give us 1 divided by root 17 divided by 9. Okay, and this is going to give us, you flip it, it's going to be 9 divided by root what? 17. So then we have cosec theta now be equal to 9 divided by root 17. So like I told you, you can't have roots for this kind of question. So because it's a sort, you have to then rationalize it. So we divide by root 17 over root 17. And if you've not watched my video on this, it's a very, very good time for you to go and watch it. And this is going to give us 9 root 17 divided by what? 17. All right. So therefore now we can now say that cosec theta is equal to 9 root 17 divided by what? 17. Then the next one, I think the next one was cot, right? If I'm not, yes, cot theta. So C, we're now told to find cot theta. So cot theta is 1 over what? Tan theta. So 1 over tan theta. So we have the same thing. Where is tan theta? So tan theta was root 17 divided by 8. So we're going to have 1 divided by root 17 divided by 8. And this is going to give me 8 divided by what? Root 17. Now, as usual, like I always say, you can have sorts as the denominator. So we have cot theta. So if you've not watched my video on rationalizing denominator, this will be a very good time for you to do that. So it'll be 8 divided by root 17 multiplied by root 17 divided by what? Root 17. And this will give you 8 root 17 divided by 17. So therefore, the cot theta will be 8 root 17 divided by what? 17. And that will be the answer for that. All right. So the final one for this was we need to find theta, I believe. Yes, and theta. So like I said, that's the D. To find the theta, you can use any of the basic trick to find it. So you can decide to use the sine theta. And the sine theta, we had it to be, I believe, root 17 over 9. Okay, you can use this, root 17 over 9. Or you can decide to use the cos theta, anyone. So if you use the cos theta was 8 over 9. Was 8 over 9, and or you can decide to use the tan theta, which was root 17 over 8. Or you can use tan theta, which was root 17 divided by what? 8. So the theta here is going to be equal to the sine inverse. You just spread this in your calculator, square root of 17 divided by 9. Or you can use this one, which is going to be the cos inverse of 8 divided by 9. Or you can use the tan inverse. So you don't need to use the three of them. So one is fine. It's just because I'm teaching a large group of viewers. So that is the reason why I'm using all of them. So anyone that you're happy with, you can use any of them to solve. And this. And when you press your calculator for that, you will find out the answer is going to be the same thing for each and every one of them. You will notice that the answer for the theta you will get is going to be 27.27. All right, and this is in what? Degrees. And that will bring us to the end for the basic trig ratio, all right? And if you watch this to the end, good job. That shows your determination and resilience to understand this topic very well. Like I always say, if you have any question, don't forget to send me an email, or if you can comment, put it in the comment section or chat me directly. I will get back to you. The next video I'm going to go to is going to be the area of a triangle. I'm going to talk about the area of a triangle. I've covered some of this aspect in other video series, but I'm going to pick a particular sect of area of triangle I've not discussed, and I will take it up from there. So it's very important that you subscribe, click the notification bell, so that when I post the next video, you'll be the first person to know. All right, I'll see you soon. Well, I'm going to talk about the area of a triangle. Have a nice day.